리서치 멘토링 프로그램은 무엇인가요? IonQ 연구자들과 직접 소통을 하며 연구를 수행하는 프로그램으로 눈높이에 맞는 연구가 가능합니다.
Hi, I'm Denny Dahl. I work in the customer success team at IonQ, and I'd like to describe briefly the four corners map coloring problem. This is a problem that I would love to work with a team on for the mentoring program this summer. So the four corners map coloring problem is a very simple combinatorial optimization problem. It considers these four states in the United States, and the goal is to place a different color in each one of the four states, subject to the constraint that neighboring states have a different color. So the point of this exercise is to show that the encoding scheme we use to represent the problem has a big impact on our ability to solve the problem. So we're going to compare two different encoding schemes. One is a unary encoding scheme, and what that means is that each of the colors that we can assign to a state will have its own qubit. The other coloring scheme is a binary encoding scheme. That encoding scheme does a more efficient job in mapping the colors to the available state space represented by the qubits. Once we have formulated the problem using both encoding schemes, we'll map the problem formulation into an energy function or a Hamiltonian, and then we'll look for the ground states of that Hamiltonian. Those represent the solutions to the problem. We'll look for the ground states of the Hamiltonians using QAOA. And what we'll find is that based on the different encoding schemes, our success in finding the ground states will be very different. I look forward to receiving your problem submissions, and I'm looking forward to our mentoring program this summer. Thank you very much. Bye-bye.
Hi, my name is Oliver Knitter. I am a quantum AI scientist at IonQ, and I will be one of the mentors in the upcoming program hosted by Sungkyun Kwan University. I just wanted to take a couple moments to introduce myself, tell you a little bit about my technical background and my previous mentorship experience, and to introduce a couple general topics that I could help out with. So I received my PhD last year from the University of Michigan in Ann Arbor in the programs of Applied and Interdisciplinary Mathematics and Scientific Computing. That's my general technical background, but my specific research experience falls more in line with AI for science, particularly at the intersection of classical machine learning and quantum computing research. In this capacity, I previously worked as an intern and then as a postdoctoral researcher for the tech startup Sandbox AQ. At the start of this summer, I moved over to IonQ, where I now work as a quantum AI scientist on the applications team. Now, while studying as a graduate student, I taught mathematics courses to undergraduates for over 4 years, primarily as the instructor of record. Additionally, over the past 2 years, while working at Sandbox AQ, I was fortunate enough to have had the chance to mentor both undergraduate and graduate students at multiple quantum hackathons hosted by New York University. I'd be very happy to work with teams on a variety of topics related to quantum algorithms, including quantum AI, quantum algorithms for solving optimization tasks, and quantum chemistry modeling. I'm also familiar with certain quantum-inspired methods in classical machine learning. That's a little bit about me. Thank you very much for listening. I hope you find this helpful, and hopefully we'll have an opportunity to work together soon.
Hello everybody, my name is Panagiotis Barkoutsos and I am participating in the mentorship program of the SKKU. A couple of words about my background. I have a PhD in theoretical physics from ETH in Zurich, Switzerland, where I focused mostly on quantum information theory and applications of near-term quantum computers. My PhD thesis was co-supervised between IBM Research and Dr. Ivano Tavernelli and ETH Zurich Professor Matthias Treuer. The title of my thesis was Quantum Algorithms for Quantum Chemistry Calculations, and one of the products that came out of my thesis was the initiation of the Qiskit nature, so the application module that was part of Qiskit relevant to physics and chemistry problems. I was developing Qiskit for quite some time in my PhD, and after that I continued in this direction. My general background comes from chemical engineering, and I have masters in computational mechanics and process engineering. Throughout my studies, I focused mostly on computational models for materials and chemistry, and also high-performance computing and data analytics. In terms of mentorship, in the past, I had the opportunity to supervise and co-supervise PhD students in different programs with focus on quantum algorithms and quantum applications. I was also honored to mentor master and bachelor students throughout their thesis, where I was the main supervisor, and all of them was again about applications of near-term quantum computers. Throughout the development of the different software packages, I was also very fortunate to mentor software engineers and people that want to develop quantum computing applications and modules that can be used for quantum computation. My main research interests lie around quantum algorithms and use cases towards quantum advantage. I have a list of selected publications that you may want to have a look in order to get a better feeling of what I'm working on and what is my interests. But to name a few, I'm very interested in hybrid quantum classical approaches, so near-term friendly quantum algorithms. I'm interested in quantum machine learning. Also, molecular dynamics and protein foldings are some topics that are of interest for me. Of course, material design, high-energy physics, error mitigation, and fault-tolerant architectures are also things that are very interesting for me. I hope that we will start working together soon, and I'm really looking forward to it. Thank you very much.